Hi everybody and welcome to this 7th video in phase equilibrium series. In this video we will be studying the phase diagram of single component system, which is our water system. So let us dive into this. So for water system, which the diagram is little bit similar but little distinct from carbon dioxide system that we have already studied. So for water system, the phase diagram happens to be something of this sort. So again there is a pressure in y-axis and temperature in x-axis. Okay. So there is your triple point. Then there is, what is unique about this is the nature of the slope in solid liquid boundary. This is solid liquid and this is your vapor phase, and this is your triple point, which means all the three phases, solid, liquid, gas, are in equilibrium at this point. So let us look at the feature of this water system. First of all, note that a very steep solid liquid boundary. May I just take this and okay. So sorry for that. Okay. So solid liquid phase boundary is very steep. So just note that point. Very steep solid liquid boundary. So this means that enormous pressures are needed to bring about specific changes in solid liquid boundary. The second point, and very important and something that is distinct from carbon dioxide, is to note that the solid liquid boundary has a negative slope. So negative slope meaning that negative slope for solid liquid boundary, meaning that melting temperature decreases as pressure is increased. See, this was quite opposite. Melting temperature increased when pressure was increased during the carbon dioxide system. Here in the water system, what happens? Since the slope is negative, melting temperature decreases as the pressure increases. Now, why is there a negative slope? Negative slope. So this, let us understand it mathematically from our Clapeyron equation, which is dp by dt was given by delta H. Okay, so since it's solid to liquid, it's delta H fusion divided by fusion temperature into delta fusion volume. Okay, now what happens is, from solid to liquid, now this is a positive value. Now this delta V fusion, delta volume, which is volume of liquid divided by volume of solid. So this is a negative value for a simple reason that ice is occupies more volume than in its liquid state. Okay, now because this is negative, your dp by dt slope, which represents the slope, will also be negative. So that is why you have a negative slope. Now the reason you should ask right now is, why is liquid water occupies less volume than a solid water? Why does ice occupy, or I'll put it this way, okay, I'll put it this way. Why does ice occupy more volume than water? Same amount. Why does that happen? Now the reason is, let me take a, okay. Now what happens is, see, in ice, that is solid water, it has got extensive hydrogen bonding. So what is hydrogen bonding? There is, due to dipole moments, there is OH, water is H2O. Now another water is H2O. But now what happens is, there is this hydrogen have a very, I would say, intermolecular forces with oxygen, this hydrogen, which is, if this is your D minus, this is your D positive, delta positive and delta negative. So because there is a charge, as simple as this, opposite charges attract each other. So that is what is happening. Since O is comparatively electronegative than hydrogen, this is negative, and hydrogen is electropositive compared to oxygen, there is a electrostatic force of attraction between oxygen and hydrogen, and this will lead to extensive hydrogen bonding. So this forms a rigid structure. So this forms rigid three-dimensional structure in ice. Next, what happens when melting takes place, that is from solid to liquid? What happens is, this hydrogen bonded structure collapses. So it partially collapses, and all your water molecules, see, when you increase the temperature, you are increasing the thermal temperature, and when you increase the thermal temperature, weaker bonds break. So these intermolecular forces of attraction, which are the intermolecular forces, these are weaker in nature, and that is why they break. So now what happens is, the water molecules collapse. The structure collapses, and that is why you see this molecules occupy less space, less volume, they become more dense compared to ice. That is why ice floats on water. That is the reason. So the other consequences of its extensive hydrogen bonding are the anomalously very high boiling point of water for a molecule of its molar mass, and its high critical temperature and pressure. So it is due to this collapse of this. In fact, the question itself should be, why does liquid water occupy less volume? It occupies less volume because the bonding, the extensive hydrogen bonding that was holding the water molecules as well as keeping them apart in ice partially collapses. That is why from this rigid structure it breaks down to a this smaller version, this lesser volume occupying structure. So that is why the slope is steeper, negative for water uh, water system, the water phase diagram, and the rest is same with regards to carbon dioxide. So with this we end water component phase diagram. Thank you so much.